this video, I'd like to show you a problem I made, and we'll work through it together. So you can take a moment to look at it, maybe try it on your own, and then we'll get to solving it. All right. Okay. So it says f of x is a quadratic in the form ax plus b and cx plus t, where a, b, c, d, the coefficients or the constants, and so on, are a part of an arithmetic sequence starting at a. Okay, and we know that f of 0 is 5. We know that the sum of the first 6 terms of the sequence is 24, and we know that one of the solutions is 1 to this quadratic that we have. Now we just need to find the term n such that the sequence will have the value of 31. Okay, so it's a lot of information, but let's just compile it, I guess. We know our function for f of x looks like ax plus b and cx plus, oh, that's not a d, there you go, d. And then we know that, let's say, term 1 of our arithmetic sequence is at a, and so on. Term 2 is b, term 3 is c, whatever. Okay, and we know that when we plug in 0 into this equation over here, we get the number 5. So let's try that real quick. When we plug in 0, this will become 0, and this will also become 0. So we essentially know that b times d is equal to 5. Okay? And we also know that the sum of the first 6 terms of the sequence is 24. Now, if you recall the formula for the sum of an arithmetic sequence, S of n, where n is the amount of terms, it's n over 2 times u1 is the same thing as term 1. I probably should use t, so t, my variable, is constant. Term 1 plus term number n, where n is the amount of terms that you have. And we know that 6 terms will give us a sum of 24. So we can plug that in and say 24 is equal to 6 over 2 times term 1 plus term 6. Now, the thing is that we don't know what term 6 is. We don't know what any of the terms are right now, but in terms of A, B, C, or D, we don't really know what term 6 is. So what we can do here to make it easier for ourselves is use some of the knowledge that we have of arithmetic sequences to essentially rewrite this into unknowns that actually relate to the question that we are solving. In other words, we're going to use the fact that in an arithmetic sequence, like, let's say we can take the simplest arithmetic sequence, 2, 4, 6, 8, like 10, 12. Alright, in this sequence, if you add the first term and the last term, sixth term, it'll give you 14. If you add the second term and the fifth term, you also get 14. And the same thing for the middle, 14. So the pattern is that algebraically, t1 plus tn is equal to the same thing as t1 plus 1 plus tn minus 1. So I think you guys can see where I'm going to go with this. We can essentially rewrite this to increase the value of t1 over here by adding 1 to it, such that it'll be one of these values, a, b, c, or d, and then decrease the value of t sub n such that it'll be one of these as well. And if we do it, we can find out that t1 plus t6 will be equal to t2 plus t5, and then that'll be equal to t3 plus t4. Now, if you look at this actually works for us because that will be C and D in our case. So essentially what we can write this is that 24 is equal to 6 over 2 is just 3, and then C plus D. Okay, so now we have another equation, which is good. And finally we can use the last given to us is that, which is that one of the solutions to this quadratic is 1. So if you have a quadratic and it's factored, we know that when you're solving for solutions, or in other words, setting it equal to 0, we can set both the factors equal to 0. And we can do that real quick. Ax plus b is equal to 0. Cx plus d is equal to 0. Okay, so now this will give us two possible equations because we don't know which of the factors are equal to 1. We know that one of the solutions is 1. So we either get that x has to equal negative b over a, or we get that x is equal to... Oh wait, never mind. My bad. This is a mistake. I meant to write... We know that one of the solutions is 1, so essentially we know that when you plug in 1 for this, then we can get 0. So we know a plus b is equal to 0, or we know c plus d is equal to 0. What we can automatically eliminate from here is that c plus d is equal to 0, because if c plus d was equal to 0, then you'd have 3 times 0 is equal to 24, which automatically does not work. So we know that this is not the case, and we know that a plus b equals 0, or in other words, a is equal to negative b. Okay, finally, because we have 4 unknowns, we would want 4 equations, and now we only have 3. This one, and this one over here. So the way we can get our 4th equation is by looking at our arithmetic sequence again and saying that, okay, we know from each term of the arithmetic sequence, we have a common difference. Let's say, I don't want to use the same variable. Common difference of, let's say, some variable, let's say c sub d. So we have a common difference of c sub d, and we can essentially write this as saying that when you subtract a from b, and then you subtract d from c, we should get the same thing. Or you can use other terms. Both, they all work. So whatever comes to mind. We just need one more equation to make sure we have 4 equations to solve for our 4 unknowns. So I'll write b minus a is equal to d minus c. Okay, that's great. Now we have 4 unknowns and we have 4 equations to solve them. So let's do this. We know a is equal to negative b. Let's substitute this over here, and we can get b minus b is equal to d minus c. 2b is equal to d minus c. Oops, that's not right. Minus c. Alright, great. And then what we can do is simplify this over here. 24 is equal to 3 times c plus d by just dividing 3 on both sides. And we know c plus d is equal to 8. Okay, now we can solve for one of these over here. Let's solve for c, why not? C is equal to 8 minus d, and then now we can put this over here and say 2b is equal to d minus 8 minus d. Get 2b is equal to d minus 8 plus d. Okay, so now we can divide by 2 over here, so we can get b is equal to d minus 4. Okay, so now we can plug in b over here, and we can say that d minus 4 times d is equal to 5. Now this is just a quadratic. D squared minus 4d is equal to 5. D squared minus 4d minus 5 equals 0. Now we can factor this into d minus 5, d plus 1. And then we will get that d is either equal to 5 or d is equal to negative 1. Okay, so we have two options here, and we have to test whether one of them works, both of them works, or none of them work. So let's just work through it. Let's take d is equal to -1 first. If d is equal to -1, then we know that c is equal to 8 minus -1, which is c is equal to 9. And then if c is equal to 9, then we know that and we know b is equal to d minus 4, so b must equal -1 close -1 minus 4. Okay, here we can automatically notice that this is not the right answer, and that is because you cannot have an arithmetic sequence going from a negative number to a positive number and back to a negative number. That means there's not a common difference between every term. So we know that the case for d is equal to -1 cannot happen. So now let's try d is equal to 5. If d equals 5, then c is equal to 8 minus 5, which is equal to 3. B is equal to 5 minus 4, which is 1. And A is equal to negative B, which is -1. And if you see, this will end up working because our sequence will become -1, 1, 3, and 5, which is a common difference of 2 each time. Okay, we are almost done with the question. We were asked to find the term number n of the sequence that has a value of 31. This we can just do by setting up an equation. We know that the first term is starting at -1, and we have a difference of 2 being applied every term minus 1. And that will be our, and whatever comes over here will be our solution to the term. And we know that we want 31 over here, and we're finding the term number that satisfies that. So that's the wrong number. We add 1 on both sides. 32 is equal to 2n minus 1 divided by 2, 16, n is equal to 17. There you go. So that was a problem. I hope you guys enjoyed it. If you guys did it in a different way and want to tell me, I'm more than happy to know how you guys did it. And yeah, see you guys later.